Chapter 3 deals with a lot of calculations. All of the notes are available in PowerPoint form on Blackboard, but some of the calculations I wanted to show you as we went through them. When you're calculating the formula weight of a compound, you really just use the periodic table. So if you're given a formula, you look at each of those terms, find the mass, and multiply by the particular subscript you might find, add them up. The mole is a pretty important thing in chemistry. You have to understand that it represents a lot of different things. It can represent atoms or molecules, or it can represent grams or even liters. When you're converting between terms, you're going to use Avogadro's number or the atomic mass in the periodic table. An element's atomic mass represents its mass in moles, or the mass of 1 mole rather, and the number of molecules is represented by Avogadro's number. And this one you're asked to convert from moles to grams. So you add up the atomic masses off the periodic table, and you find that 1 mole is 63.018 grams. Since you don't have 1 mole, you simply convert between them. Notice here that your mole term has to cancel out. And you round to significant figures always. So look through these next couple of slides, and again refer to the slides that are just normal PowerPoints to make sure you understand. And we'll move on to the more complicated math. I also have listed some videos on my YouTube channel that I didn't create that I think might be useful to you. Feel free to use those, and if none of them work, just let me know. Alright, an empirical formula calculation is pretty simple. The empirical formula is the one with the lowest integer subscripts. You can have decimals or fractions. If it's reduced and to the point it can't be reduced any further, it's empirical. When you're going to calculate one, you have to convert grams to moles of each term, and you assume 100 grams if you're given percentages. You're going to convert each one to moles and divide each of those moles by the smallest value to get whole numbers. So in this one you have 92.3% carbon and 7.7% hydrogen, and I want the empirical formula. I'm going to assume that those percentages are the same as grams and convert each of them to moles. And I find that I have 7.685 moles of carbon and 7.64 moles of hydrogen. In order to determine the formula subscripts, I divide both of these terms by the smaller of the two. And I get approximately 1 for each one. The general rule in this is if you divide them out and they're within 1/10 of the whole number, you can round it. Otherwise, you've got to multiply to get rid of your fraction. So your empirical formula is just CH. Molecular formula gives you the actual number of each term. To calculate it, you're simply going to find the empirical formula and determine its weight, and then find the ratio of the molecular weight to the empirical formula weight. Then multiply the subscripts in your empirical formula by this ratio. For example, we found that the empirical formula of benzene was CH, and its molecular weight is 78. The empirical formula weight is 13, so if I divide 78.1 by 13, I get 6. So I take the subscripts in CH and multiply them by 6, and I get the molecular formula. In this particular example, you have percentages again, and that's for empirical. So I convert each one to moles. And in this case, you see you don't have the same value. So I look at these three, and I pick the smallest one, which is obviously 0.7523, and I divide all of them by that value. What I do, as you see, you get almost exactly 2 for sodium, 1 for phosphorus, and 3.5 for oxygen. You can't round that 3.5, so I have to get rid of it. I multiply by 2 to get rid of the half. You would multiply by a 4 for a 0.25 or 0.75 ending, and by by 3 if you have a 0.33 or 0.67 ending. So you can look at the next couple of examples, and again, look at the ones that are in PowerPoint form, so you can take your time in going over them. The most important thing that I needed to show you in this chapter is stoichiometry, and it's the relationship between terms. You can calculate how much of a product will be formed if you know the reactant masses, or you can calculate how much of a reactant you need if you want a particular mass of a product. First of all, the chemical equation is the most important thing in this. It tells you how much of each term is needed relative to the other. When you're doing a problem, you're going to convert grams of a certain substance to moles, because the coefficients of a reaction are indicators of the moles. Then you use the coefficients to determine the conversion between moles of first substance and moles of the second, and then on to grams. If you look at this diagram on the bottom, it sort of puts it in perspective. To convert grams to moles, I multiply by 1 mole over grams, which allows me to calculate moles. Then I multiply by the coefficient of what I want and divide by the coefficient of what I have, which converts to the second term in moles, and then convert that. For example, if I have this equation, I'm told that I have 20 grams of propane, and I want to know how much CO2 is formed. In the equation, I have a 1 as a coefficient of propane, which indicates I have 1 mole, and a 3 for CO2, which indicates I have 3 moles of CO2. That tells me that for every 1 mole of propane, I need 3 of CO2. I have to determine what amount of moles I have so I can use that relationship. I convert 20 grams to moles in this first step, and then I multiply by the coefficient of CO2, and I divide by the coefficient of propane, and then I multiply that by the mass of CO2. And if you look at all the units, everything cancels except grams of CO2. So do a couple of examples. Please feel free to look at the other videos that I've put up. A limiting reactant problem is also something you need to consider. Basically, it's the reactant that runs out first. When you're doing a calculation, you do the exact same thing. You just have to do a calculation for more than one reactant. Excuse me. So you're going to use that stoichiometric process to determine the amount of product, and then the limiting reactant produces the smaller amount. Exactly the same setup as we did before. Now I have 2 values, though. I have a value for your zirconium chloride and a value for just magnesium, and it wants to know the moles of zirconium produced. From the zirconium chloride, I can get 0.2 moles of zirconium because I have the same coefficient in the balanced equation. And from 0.5 moles of magnesium, I can produce 0.25 moles of zirconium looking at the coefficients. Since a smaller amount of zirconium is produced in the first process, zirconium chloride would be my limiting reactant. And furthermore, the amount produced, or the yield produced, is the smaller quantity. So it's important that you realize that the quantity produced is called the theoretical yield, and the element or compound formula is the limiting reactant. So look through these next few examples. Most of it is self-explanatory. I just wanted to look at a few things with you. As you're doing these, let me know if you have any problems for this first test, and look over your definitions and everything from chapters 1 and 2. If you have any questions or need further help, please don't hesitate to email me. You guys have a great day.